Hello, welcome back. So in this part, we are going to discuss about the equivalent area. Although I have introduced this equivalent area concept in the previous part also. So now we are going to discuss in more detail about it. So equivalent area or equivalent section, it is sometimes also termed as transformed section. And we have discussed about it in detail in the previous lecture also when we were discussing about the singly reinforced beam. So the same concept we will apply here. So equivalent area or transform section of a given doubly reinforced beam in terms of concrete, it is shown in the figure. So in case of doubly reinforced beam, the active or effective area which we generally consider in our calculation is equivalent area of the steel, which is M into AST. Similarly, the area of the concrete which is carrying the compression. And now as we have provided steel in the compression side also, so we will replace that steel with the equivalent area of concrete also. So this increased part of concrete, it is actually showing the equivalent area of concrete in compression, and it is being provided in place of the steel. Now basically in this equivalent section, so first of all we will talk about the tensile steel area. So we already know that tensile steel area is replaced by equivalent area of the concrete, and the formula for that is M into AST. So the same formula we are using here as it is. And if we try to find out the stresses in this equivalent area of concrete, it will be given by sigma st by M. So the same values we used in the singly reinforced beam also. So the same thing we are following here when we are talking about the tension steel. Now in the same line, we are going to find out the value of equivalent area of concrete in this zone, which we have provided in place of steel in the compression zone. Now talking about the compression area, well, tension area only consists of this area, but compression area consists of this concrete area plus this one and this one. So if I say this as 1, 2 and 3, so 1 is this area which is the actual area of concrete above neutral axis, which is carrying the compressive force, and this area 2 and 3, it is actually the equivalent area of concrete which we have provided in place of the compressive steel. So if we find out the total compression area, so total compression area will consist of the area of concrete above neutral axis excluding the area of compressive steel, which is B into X. So B is the width of concrete, this B, and this is the X. So this value, sorry, up to this value. So this is the X. So B into X. So total area minus the area of cross section of the steel. Okay. So this is the one part which is this one. Now B part is the area of compression steel, ASC. Now ASC is replaced by the equivalent area of concrete, which is M dash into ASC. Like we used to find out for AST, we have replaced, I mean, if we try to find out equivalent area of concrete in tension, we have written M into AST. On the same line, as we are replacing the reinforcement bar, like these are the reinforcement bars, so we are replacing these reinforcement bar with the equivalent area of concrete. So the formula for this will become M dash into ASC. So M dash we are using because the steel is in compression, and as I have already discussed that modular ratio will be increased in this case. So M dash value is actually 1.5 times of M. So in this case, the equivalent area of the concrete in compression zone will become 1.5 M times of ASC. Similarly, in tension zone, it will be M into AST. Okay. So now the total area in compression zone will be area of concrete above neutral axis, excluding the area of compressive steel, plus area of compression steel, which is being replaced by the equivalent area of concrete, which is m dash into ASC, or 1.5 times of m into ASC. So now if we sum up this, we can write, so net compression area will be B into X, it is the total area, minus ASC plus this one. So you can see this part is A and this part is B. So this one and this one. So BX minus ASC plus 1.5 times of M into ASC. So by solving it, we will take ASC common from this. So ultimately this will become BX plus 1.5 times of M minus 1. So there you can see now this value is actually this one, half this side and half this side. So if we sum up this value, it will actually come up to this one. So I hope this is clear to you now. So that is the equivalent section. Now similarly, if we try to find out the equivalent stresses in this concrete area, if we try to find out the stresses in this equivalent area, so we represent by FCBC dash. So at this level, so this value is actually FCBC dash, and FCBC is the stress in concrete, flexural compressive stress in concrete. So like we used to do in case of a singly reinforced beam, so here the stress in equivalent concrete area, which is M dash ASC, will be FCBC, and we can calculate this FCBC value or stresses in steel by using this formula. So this is the same formula that we used to calculate for actual stress in tension steel, which is M into sorry. So to calculate the value of FSC, it will be M dash into FCBC. So this is the same statement that I have discussed earlier when I was discussing about the modular ratio. So I will show you that statement again. So there you can see this is the statement which is being provided as per IS code. So as per IS code, it says the compressive stress in steel in the compression zone is calculated by multiplying the stress in surrounding concrete by 1.5 times of M. But this value should not exceed the permissible stress, which is sigma SC in steel bar in the compression. So the same statement, as per this statement, we can find out the actual compressive stress in the steel by using that formula. So I'm again showing you that. So therefore FSC becomes M dash into FCBC. So FCBC is the flexural compressive stress in the equivalent area of concrete. So to calculate the actual stress in steel, we used this relation. Similarly, if we replace M dash by this, so this value will also become like this. Also, using this relation, we can also calculate FCBC dash as FSC by 1.5 times of M. So this also becomes the relation. So we will discuss more about it in the next part. Thank you.